Hello everyone, I am Rupali Kund, a final year student at Sri Sant Gajanan Maharaj College of Engineering. I am currently an intern at Immertex Information Technology. This internship based on embedded systems, and today we are talk about our internship project named as Microwave Oven Simulation, and also we talk about what topics we learned during our internship program. So let me start here. Firstly, we see the contents. Introduction to C programming, embedded system, components of embedded system, microcontroller, microprocessor, PICSimLab, CLCD, matrix CPD, ISR, interrupts and timers, project implementation. Then the topics learned during our internship is Introduction to C programming, arrays and pointers, functions and string, conditional statements, loops and operators, storage classes, and the main thing is the introduction to embedded system. What is microcontrollers? MPLAB IDE, PICSimLab, introduction and interfacing of various peripherals of PIC16F877A. Also, weekly quizzes and Disha workshop. Then, firstly, we talk about what is microwave oven. Basically, a microwave oven is a kitchen appliance that heats and cooks food for microwave. Microwaves causes water molecules in the food to vibrate, which produce heat. Microwave ovens are very efficient at heating food and can cook food quickly and evenly. Microwave ovens are commonly used to reheat food, but they are they can also be used to cook a variety of foods including vegetables, meat, poultry, and fish. Microwave ovens can also be used to bake cake, cookies, and other desserts. Also, a convenient and versatile kitchen appliance, but it is important to use them safely. Always use microwave safe cookware and do not overcook food. Then following four is the microwave oven operator modes which we can use in our project. Firstly, microwave mode. A microwave mode is a mode in which the embedded systems uses microwave to heat food. Microwaves are a type of electromagnetic radiation that can heat food by causing the water molecules in the food to vibrate. Micro mode is often used to cook food quickly and easily. The second one is a grill mode. A grill mode is a mode in which the embedded system uses a heating element to grill food. Grilling is a cooking method in which food is cooked by direct heat from above. Grill mode is often used to cook meat, fish, and vegetables. The third one is convection mode. A convection mode is a mode in which the embedded system uses a fan to circulate hot air around the food. Convection mode is often used to cook food evenly and quickly. Convection mode is often used to bake cakes, cookies, and other baked goods. The last one is start mode. I am not familiar with the term of this mode in the context of embedded system. It is possibly that it is proprietary mode specific to embedded system. In the first week of internship, we learn embedded C programming. Basically, the embedded C programming is a subset of the C programming language that is used to develop software for embedded systems. In C programming, variables store data, functions execute tasks, and control flow statements manage execution paths. Also, the arrays store multiple values, pointers handle memory addresses, and the structures group variables. As skills advance, programmers encounter dynamic memory, file handling, and advanced data structures for complex programs. Then, what is embedded system? An embedded system is a computer system that is designed to perform a specific task or a set of tasks within a larger system. Embedded systems are often found in consumer electronics, industrial control systems, and automotive systems. Embedded systems are typically smaller and less powerful than general purpose computers, but they are also more efficient and reliable. Embedded systems are often designed to operate in real time, meaning that they must be able to respond to events in a timely manner. Here are some examples of embedded systems: microcontroller, digital signal processors, field programmable gate arrays, system on a chip devices, embedded Linux system. Also, here are some of the key characteristics of embedded system. First one is a specific purpose, means embedded systems are designed to perform a specific task or a set of tasks. For example, a microcontroller in a microwave oven is designed to control the cooking process. Second one is the real-time operation. Embedded systems often need to operate in real time, meaning that they must be able to respond to events in a timely manner. For examples, an embedded system in a car engine needs to able to respond and changes in the engine speed or temperature very quickly. The third one is the resource constraints. Embedded systems often have limited resources such as memory and processing power. This is because embedded systems are often designed to be small and efficient. Last one is reliability. Embedded systems need to be reliable. This is because they are often used to control critical systems such as car engines and medical devices. Then, what is microcontroller? A microcontroller is a small integrated circuit computer that is designed to perform a specific task or a set of tasks within an embedded system. Microcontrollers typically include a central processing unit (CPU), memory, and input-output peripherals on a single chip. This makes them ideal for embedded systems, which often have limited space and power constraints. A microwave oven is an example of a microcontroller, and microcontroller in a microwave oven controls the cooking process, including the heating elements and fan and a timer. This is the main part of our project. Also, PICSimLab. A PICSimLab is a software simulator for PIC microcontrollers. It is a popular tool for embedded systems development as it allows users to develop and test their code without the need of physical hardware. Also, here are some of the benefits of using PICSimLab in embedded systems development, which is reduce development time and cost, improve code quality, increase flexibility. And a PICSimLab is a valuable tool for embedded systems developers of all skills levels. It can be used to learn about PIC microcontrollers, develop and test embedded code, and debug embedded systems. CLCD. CLCD stands for Color LCD and it's a type of LCD display that can display colors. CLCDs are commonly used in embedded systems as they are efficient, reliable, and can be used to display a wide variety of information. CLCDs use a variety of technologies to display colors, but the most common is the thin film transistor. TFT technology. TFT technology uses a grid transistor to control the flow of current to each pixel on the display. This allows for precise control of the color and brightness of each pixel, which results in high quality images. Also, the CLCDs are used in a wide variety of embedded systems such as smartphones, tablets, digital cameras, GPS devices, car dashboards, medical devices, industrial control system, and energy efficiency. Next one is MKP. Matrix keypad. A matrix keypad is a type of keypad that uses a matrix of switches to represent the different keys. It is a common type of keypad used in embedded systems because it is simple and inexpensive and reliable. A matrix keypad typically consists of grid of rows and columns with each row and column connected to a microcontroller pin. When a key is pressed, it connects the corresponding row and column, which generates a signal to the microcontroller. The microcontroller can then determine which key passed or which key was pressed by reading the signals on the pins. Also, however, matrix keypad can be susceptible to ghosting, which is when the microcontroller registers multiple keys as being pressed when only one key is actually pressed. Ghosting can be caused by factors such as noise on the microcontroller pins or multiple keys being pressed simultaneously. Then ISR. Basically, the ISR stands for Interrupt Service Routine. It is a function that is executed in response to an interrupt. An interrupt is a signal to the microcontroller that an event has occurred that needs to be handled immediately. Also, the ISRs are used in a wide variety of embedded systems applications such as real-time control systems, communication system, and in device drivers. The real-time control system in which ISR are used to ensure that real-time control systems respond to events in a timely manner. And in communication system, ISR are used to handle incoming and outgoing data in communication system. And the third one is a device drivers in which ISRs are used to handle events generated by devices such as button press or sensor reading. Also, the ISRs are an essential part of many embedded systems. They allow embedded system to respond to event in a timely manner and to perform complex tasks. Microwave oven is the best example of ISR, and in a microwave oven, an ISR might be used to handle the press of a button to start or to stop the cooking process. In last is the interrupts and timers. Interrupts and timers are two essential components of embedded systems. Interrupts allow embedded systems to respond events in a timely manner, while the timers allow embedded system to perform tasks at regular intervals. Interrupts and timers can be used together to implement a wide variety of embedded systems functions. For example, an interrupt can be used to handle a button press, which can then start a timer. The timer can be used to generate a PWM signal to control a motor. Also, microwave ovens is the best example of interrupts and timers. And in a microwave oven, an interrupt might be used to handle the press of button to start and stop the cooking process. The timer is used to control the cooking time. Interrupts and timers are two essential components of embedded system. And another example of a communication system that uses a timer to generate the start and stop bits for serial communication protocol. When the timer expires, the microcontroller generates an interrupt to handle the next bit of data.
Now this is the PICSimLab simulator on which the microwave oven project was deployed. As we can see, has the PIC16 FH77A microcontroller integrated in the simulator. In our PICSimLab simulator, we come to know that LEDs are connected to port B and port D. On the left side we have the matrix keypad I am going to use in order to perform specific tasks in the simulation. As mentioned previously, tactile switches are connected in rows, in columns and format. On the right side at the top we have the coder that we start running once we start the microwave over the CCD we can using it's the one that having the HD4478 interface that will print 4 lines. On the each line we can print 16 characters. Now let me show. Upload the code. In order to start, if we powering on, and it will be redirected to the menu. On the menu screen we have 4 options: send for micro mode, 2 for grill mode, 3 for convection mode, and 4 for start. I am going to press key number 1 to start the micro mode. It will show the power on 100 bs, and it will be redirected to the screen where we can enter the time in seconds and minutes. I am going to enter seconds and minutes. Now we can use the key if we want to clear the time that was already entered, and press the hashtag key if you want to start the oven. Now we can see it's the oven is running, also the cooler is running. Now if we press key number, if suppose 4, it will be increase the time by 30 seconds. As we can see, the time was already increases. If you want to pause the oven, we can press key number 5, and the oven is pass. If you want to start again, then we press again a key number 4. Now the oven is running again. As it shows on the menu screen, we press the key number 6 and the oven is stopped. Now let's see the option 2, which stands for grill mode. I am going to press number grill, and it shows the screen where you can enter second and minutes. We can use the key if you want to clear the time and press the hashtag if you want to start the oven. Now when the time will reach by 0, the oven will time out and the buzzer will make a sound here. And we like this one. Now let's see option number 3. This stands for convection mode. I am going to press key numbers 3. Here we have a screen where we can enter the temperature. I am going to enter the temperature, and we can use the key if you want to clear and enter a new key and press the hashtag key to start the preheating mode. When the preheating mode will be completely, the screen will be directed to another screen where we can enter the key. Okay, I am going to enter second and press the hashtag key. Now we can see that it open it and it is running. Now if you press key number 4, it will increase the time by 30 seconds. If we press key number 5, it will pause the oven. Now we can see that it's pause and starts again by pressing key number 4. Now you can see that oven is running again, cooler is. And we have another option, key number 6. If you want to stop the oven, I am going to press it to see, and it's work. The cooler is stopped. And now let's see option number 4. If you press key number 4, the oven will start. As we can see, the oven is running, the cooler is running, and when the time will reach at 0, the oven will time out and the power will make a sound. So now let's wait for some time to begin. And it timing out. So that's all about the presentation.